auction wasn't a first price auction, I had the same decision problem. If the auction wasn't a first price auction, but a second price auction. Okay, two bidders, second price auction, two bidders. You do the three bidders by yourself. Second price auction, two bidders. What would you expect? Will the answer be any different? In general, first, pay attention, okay, intuition here. In general, when you are conducting one particular auction, the outcome of the first price auction and the outcome of the second price auction will be different. No reason why they should be the same. If you are conducting a particular auction. What we mean by a particular auction is that when bidders know their sets of valuations. That's a particular auction. Here, do bidders know their valuation? What valuations are they using? The average valuation. And if bidders are using their average valuations and making their bids based on those average valuations, what do we know about first price and second price auctions? They will generate the same price on average. You know that? Revenue equivalence theorem. Revenue equivalence theorem. Show you. Suppose this is the second price auction, okay? Two bidders. Probability of winning and losing, does it change? No. You still remain half. The green is for second price, huh? So you still remain half. Probability of losing half, probability of winning is half. Okay. Let's consider what happens in a second price auction. 0, 15. Second price auction. I have to figure out what will happen if I lose. Lose, no problem. 0 minus 2.5, still minus 2.5. If I lose, I'll get minus 6.5. Let's see what will happen when I win. Win, again, the same problem. I don't know my valuation. In order for me to win, I must have the highest valuation. Therefore, on average, if I win, my valuation will be here. Divided into 3 parts, 10. My valuation will be here. But this is the second price auction now. I will not pay my valuation. I will pay the next highest bid. The next highest bid, second price auction. What is bidders' dominant strategies? To bid their valuation. So if this is, on average, this is the highest valuation. On average, this is the second highest valuation. If we use our dominant strategies, the highest valuation guy will bid 10. The second highest valuation guy will bid 5. Therefore, I will win the auction, but how much will I pay for it? 5. Therefore, my payoff from winning the auction will be 10 minus 5. Therefore, my overall payoff will be 10 minus 5 minus entry fee, which is 2.5. So therefore, my expected payoff at this probability node under a second price auction will be half 2.5 plus half minus 2.5, which is 0, same as before. Okay, ladies and gentlemen, more important, the calculation. You must be able to see the mechanics of the thing that is going on. Even before you answer the question, what will the results be different with a second price auction? Even before you show it to me, no, it will not be different. You should be expecting. I am using average values. Bidders don't know their valuation. If bidders knew their valuation, no way will you get the answer. You might get the same answer, right, with first price and second price. But chances are you won't. Okay? There's a great chance you won't. But if it is, if bidders don't know their valuation, then the revenue generated from a first price auction, that means the price you will pay in a first price auction, will be the price you will pay in a second price auction. Your valuation will be the same in a first price auction. Valuation is independent of the auction type, therefore your payoff will be the same in a first price auction and in a second price auction. On average, your payoff will be the same from in a first price auction and in a second price. And the equation is pretty clear. What your valuation is does not depend on what auction format you are using. What price you pay is the same under both auction formats on average. Therefore, the payoff you get from winning, which is valuation minus price, must be the same on average between the two options. Okay, guys. Questions?